Assalamu alaikum everyone, and today we are going to be talking about equilibrium. Now sometimes chemical reactions aren't unidirectional, they are reversible. So that means there's a forward and backward reaction. When the rates of the forward and backward reaction are the same, we call it a dynamic equilibrium. Now chemistry is happening here, but since both forward and reverse reactions are happening at the same rate, there doesn't seem to appear to have any activity going on. We learned to use stoichiometry to discuss limiting reagents and how much of the products to expect, but those were for unidirectional reactions. But at equilibrium, it's a little more complicated to calculate what the concentration of each substance will be. Let's look at an equilibrium. Here we have phosphorus pentachloride. I believe that's what it's called. And it's having equilibrium with phosphorus trichloride and chlorine gas. Now let's say we have 1 mole of phosphorus pentachloride and 0.13 moles of phosphorus trichloride. So how much of the other two things are there? To answer this, we have to make an ice box. No, not the ice boxes you are thinking of. No, this ice here is a portmanteau of initial change equilibrium. So let's make an ice box here. Now the initial concentrations will be 1 mole for phosphorus pentachloride and 0 for the products, as initially we won't have any products. Now the change for the reactants will be minus X as it's being depleted, and plus X for the products. Now the equilibrium will be 1 mole minus X for phosphorus pentachloride and X for phosphorus trichloride and chlorine gas, because 0 plus X is equal to X. Now X is 0.135 because we have 0.135 moles of phosphorus trichloride. So we will have 0.135 moles of phosphorus trichloride and 0.135 moles of chlorine gas, and for the phosphorus pentachloride we will have 0.865. Every equilibrium has an equilibrium constant, Kc. Kc will be the concentration of the products raised to their coefficients divided by the concentration of the reactants raised to their coefficients. Now this is the difference between this and the rate laws. In the rate laws, it's being raised to the power of order with respect to that substance. Here it's going to be the coefficients. Now this is called an equilibrium constant expression. If Kc is much bigger than 1, then the numerator is bigger, so it will produce more products. If Kc is much smaller than 1, then the denominator is bigger, and therefore there will be more reactants. Now let's say we have this reaction with water gas plus solid carbon will turn into carbon monoxide and hydrogen gas. Now see here in the equilibrium constant, we are not going to be discussing solids or pure liquids in this expression. We are only going to discuss gas and aqueous. See here, we are not going to discuss solid carbon because it doesn't make sense to have a concentration of something solid. Sometimes we want to predict which way will a mixture go given non-equilibrium quality. For that, we have a reaction quotient. We plug in the non-equilibrium quantities, and if Kc is bigger than Q, then it'll favor products to equilibrate. And if Kc is much smaller than Q, then it'll favor reactants or make more reactants to equilibrate. If Kc is equals to Q, then we're at equilibrium. Now with the following, let's find the Kc and Q. The Kc is already given, 0.016, and so according to this information, we can make an ice box. 0.5 moles divided by 5 liters will be 0.1 molarity, and the products will be 0, 0. Now the change will be minus 2x for the reactants and plus x for the products. And to equilibrate, now equilibrium will be 0.1 minus 2x, and for the products it'll be x. Now let's plug in the concentrations. Now luckily both the numerator and the denominator is squared, so we can take the square root. If it wasn't so simple, we would use the quadratic formula, but since this is simple, let's take the shortest route. And 0.126 equals to x divided by 0.1 minus 2x, and with a bit of algebra we can find that x equals to 0.01. So the concentration of hydrogen and concentration of iodine is 0.01 molar, and the concentration of hydrogen iodine will be 0.08 molar. Now let's calculate the reaction quotient. We are going to multiply 0.01 times 0.01 divided by 0.08 squared. So now we can square the numerator as they are basically multiplying by each other, and if we plug it into our calculator, we get this number. So Kc is much bigger than Q, so it'll make more products to be at equilibrium. So that's all there is to it. Thank you for watching. If you want more videos about math and science and want to improve your knowledge on that, please make sure to subscribe to my channel and leave a like down below if you liked the video. And if I made any errors with my calculations or error with the information in general, or if you are just confused about something, then please let me know down in the comments. And thank you for watching, and I will see you next time. Bye.